on with what we've been doing in statistics. Today, we'll look more at the normal distribution and also look at z-scores and percentiles. Homework 16, which is on that finding the standard deviation and those other measures of dispersion, is due today. Homework 17, I pushed back a little bit because I realized that homework 17 includes the margin of error, and I don't think we're going to talk about the margin of error before Friday. And homework 18, it includes some of what we're doing with the normal distribution. I don't agree with where Mr. Blitzer hits the margin of error, so that's usually the last thing that we look at. Before we get started, does anybody want to look at any questions from the homework? Does anybody have any issues with any of the measures of central tendency or the measures of dispersion? Any questions on that? Homework 16, finding the standard deviation. Does anybody want to look at any of those, or are you guys all right?
The ones that were the long ones that have multiple questions, for some reason I kept getting partial credit on those.
All right, let's scroll through and see if we can find one. Range was pretty straightforward.
Yep.
These, the deviations from the mean.
Is that the ones that kept having questions? Once you enter that, you have another question and another question?
There's just A and B, but you had to fill in the table.
No, that wasn't the one.
Okay.
Nope.
You had to find the mean, the deviations, and the sum of the deviations.
Correct.
Is this one that you're wondering about?
I think that might have been one of them.
Okay, so my data values are 54, 94, 74, 54, and 114. And so those add up to 1, 2, 3, 4, 5, 20. I'm gonna 54 plus 94 plus 74 plus 54 plus 114. So those add up to 390. And so the mean is that 390 divided by 5, which gives me 78. And so for my deviations from the mean, I'm going to just subtract 78 from each of those. So 54 minus 78 would be negative 24. 94 minus 78 would be 16. 74 minus 78 would be negative 4. 54 minus 78 would be negative 24. And 114 minus 78 would be, I'm going to cheat with that one, 114 minus 78 would give me 36. And so now when I add all of those, 36 plus negative 24 plus negative 4 plus 16 plus negative 24, they should add to 0. So that these would be your deviations. And then part C, the sum of the deviations is 0.
Okay. I found the one that I was having partial credit is number 13.
Okay. Okay, so the data sets give the number of platinum albums for the 5 male artists and 5 female artists with the most platinum albums for recent year. A says the male artists, I have to apologize. I'm having trouble with my eyes this morning. Let's see if I can make that bigger. the male artists have the greater, without calculating which set has the greater mean and why. So as I look at the values for the men, do you notice how they're pretty much all higher than the women's values? And so that would be the greater mean. So the male artists have the greater mean because all the data values for the males are greater than those for the females. Verify your conjecture by finding the mean for each of them. And so did you go ahead and find the average for each of them?
Yeah.
For the men, the 147 plus the 98 plus the 88 plus the 81 plus the 69. Those add up to
And then we divide it by 5, right?
483 divided by 5. That mean is 96.6. And then the mean for the women, we'd have to add them up. So their total would be 68 plus 66 plus 58 plus 56 plus 44. And so that adds up to 292. And so when I take that and divide it by 5, their average is 58.4. Damn it. They say it around to 2 decimal places is needed. I don't think we need 2 decimal places. 58.4. Let's see if they yell at me for rounding. No, they don't. Without calculating which has the standard deviation. Well, if I look at the spread in the men's, you see how the range for the men's is much higher than the range for the women's. So I would say that the male have the greater standard deviation because they have a greater spread. And then they want you to find the standard deviation for each. And so to find the standard deviation, we would have to go through for each and find the actual standard deviation. So go ahead.
That's where I got stuck.
So that's the value, the mean for the men. Are you all right if we just do one of the two?
Sure.
And so the men's was 147, 98, 88, 81, 69. The mean we said was 96.6. So I'm going to take 147 minus 96.6, gives me 50.4. And while that's in my calculator, I'm just going to square it. So that gives me 2540.16. Then next one, 98 minus 96.6 is 1.4. With that in my calculator, I'm going to square, 1.4 goes here, I apologize. I'm going to square that and that gives me 1.96. Then the 88 minus the 96.6 gives me negative 8.6. Remember, when you square it, you should get a positive. When I square it, I get 73.96. Then I'm going to take the 81 minus the 96.6, which gives me negative 15.6. And then I'm going to square that and get 243.36. And lastly, I'll take the 69 minus the 96.6, which gives me negative 27.6. And I'm going to square that, which gives me 761.76. So far, so good. Then I'm going to add all those numbers, the 761.76 plus the 243.36 plus the 73.96 plus the 1.96 plus the 2540.16. And so that adds to 3621.2. Now what you have to remember is we're going to take that number, and for the mean we divide it by 5, so this number we're going to divide by 4, which gives me 905.3. And then for the standard deviation, I'm going to take the square root of that. And so my standard deviation is, do they give me round off places? My standard deviation for the men I'm getting is 30.088. Round to do decimal places is needed. So that would be 30.09, rounding up. And then you'd have to do the same for the women.
What I need to know is on the second column, how come, where's the 1.4 come from? I thought
that was a typo on my part.
Okay. So
That
that column is going to be all 96.6, right?
Right.
And
Yes.
then I just need to ask this. I'm sorry, I don't want to hold up anyone. So then we'll do 147 minus 96.6. That's how we get the 50.4. Where's the 2540.6 is coming?
We're taking that. Do you see how? There's a typo here too. Do you see how this column is, the heading is the difference, right? It's this number minus this number. Do you see how this column, it's that same quantity, but then we square it. So you're just taking that 50.
Oh, okay, that's what I missed, the square. Okay.
Better?
Yeah, better. That's all I needed to know.
All right. Anybody else have any questions on any of the homework?
I understand why I got the partial now. I see.
Good.
All right. Now, when we do the square, we have to make sure it's in the parentheses, right?
You want to make sure when you square it, your answer should always be positive. So putting it in parentheses is good. Although if you have that number right on your calculator, you can probably just hit x squared and not re-enter it, and it squares your last answer, which is why I fill it in going sideways, so I don't have to type those numbers in a second time.
Right. Thank you so much.
You're welcome. Anybody else have any other homework questions? If not, we had left off, yeah, that's what I want. We had left off looking at that 68, 95, 99.7 rule to the normal distribution. And we kind of spelled out what it meant, but we didn't look at examples using it. And so I'd like to start today by looking at 2 examples of that. And then let's go on and let's look at what a z-score is. So when we were looking at the normal distribution before, we had said that American men's heights are normally distributed. Next example, something else that's normally distributed are IQ scores. So IQs are normally distributed. On one IQ test, the mean is 100 and the standard deviation is 16. We're going to use the 68, 95, 99.7 rule to find a whole bunch of things. Now, before I list the rest of the question, I want to stress
Whenever I see this phraseology, use the 68, 95, 99.7 rule. The first thing that I do is I go through and I draw that bell curve. We had said when we label the bell curve for this rule, we're always going to start in the middle. And on the axis, the number in the middle is going to be our mean. So what value should I put down here? The mean is 100. And then we said we're going to count to the right and count to the left. But when we move to the right, move to the left, what we're going to add on is always our standard deviation. So I'm going to go 100 plus 16 would be 116, plus another 16 would be 132, plus another 16 would be 148. Get our rule had 3 parts, so we want to go 3 16ths to the right, and then we want to go 3 16ths to the left. So 100 minus 16 would give me 84. 84 minus 16 would give me 68. And 68 minus 16 would give me 52. At which point, I think I want to put a break in the axis because the space from 0 to 52 looks off. Is everybody comfortable with where those numbers came from?
Yeah.
That the next thing we want to do is we want to put our little boxes for our percentages. If I go 1 to either side of the middle, that's my middle 68%. Then if I go to the next number out on each side, that next grouping will be my middle 95%. And then if I connect the third one on each side, that's my 99.7%. We spent a lot of time last class going over and developing those. Now let's use them to answer the questions. First, let's find the percent of people with an IQ between 68 and 132. This one I'm going to color code these the first time. 68 and 132. 68 is here. 132 is here. And if I follow up, does everybody see that that gives me the entire box for 95%? And we just read that one right off the graph. That one okay?
Yeah.
Next one, we want to find the percent of people between 84 and 100. 84 is here. But let's see, 100, that's my middle. So 84 is part of the 64%. But you see how we're only taking up to the middle? Because of the symmetries, wouldn't that be my 68%? But I'm only taking one side of it, so I'll divide it by 2 and get 34%. That one, all right. Well,
Yeah.
middle, so we're only taking half. If I want the percent between, this time let's look for the percent between 116 and 132. Well, 116 is the boundary for 68%, and 132 is the boundary for 95%. And so this part here, wouldn't that be, to start with, do you see how we would have to take the difference between the 95% and the 68%? But where that gets a little dicey is because the difference between the 95% and the 68%, well, I've got that difference on this side, but isn't also part of that difference over here on the other side. And I don't want both sides. I just want one. So we're going to subtract and then divide by 2. Again, we're dividing by 2 because here we're only looking at one side. So that'll give me 27 over 2, or 13.5%. And so if I've got two different boundaries, I'm going to subtract the percents affiliated with them. And if I'm only looking at one side of the curve, I'm going to divide it by 2. That one all right.
Yes.
And the next one asks us to find the percent with an IQ above 132. Well, above 132 would be everything to the right of 132. And as I look at that, do you see how we're even going outside of that 99.7? So I'm not going to subtract from the 99.7. If I want everything above a value, I want the rest of the population at 132 is my 95%. But when I see that word above, I'm going to take the difference from 100. And again, because I'm only on one side, I'll divide by 2. So that would give me 5 divided by 2, or 2.5%. And so if I'm looking at words like above or below, I subtract the percent from 100. And if I'm only on one side, I'm going to divide by 2. And you see how once we have the picture drawn to answer all of the questions, we're just going to read our answers off the graph. If I've got straightforward boundaries, it's just that percent. If I'm going up to the middle, I'm only taking half of that percent. If I'm looking between two boundaries, I have to subtract. And if I'm only looking between the two boundaries on one side, not both, I divide by 2. Should we try another one?
Please.
All right. Next example. Did anybody here ever take the SAT exam?
Yeah.
And the SAT exam, any one content area, let's say math, the results are normal. So they're normally distributed. The mean, they're scaled so that the mean is 500 and the standard deviation is 100. And so whatever the results are, if after everybody takes the test, they scale it so that you have a mean of 500 and a standard deviation of 100. That's consistent. So now let's go through and let's use the 68, 95, 99.7 rule to find a whole bunch of things. And whenever I hear those words, I draw my bell curve. When I label my bell curve, I start in the middle. This time, what should my middle value be?
500.
Beautiful. And then I want to go 3 to the right and 3 to the left. This time, as I go to the right, what should I add on?
100.
100. So this would be 600, 700, 800. And then the other direction will subtract to get 400, 300, and 200. Then I'm going to go 1 on either side. That'll be my 68%. Then if I go to the next one on either side, that will be my 95%. And when I connect the lowest and the highest, that'll be my 99.7%. And I'm looking at it, and I probably should put a break in the axis because that space between 0 and 200 doesn't look quite right. And so, has everybody got their picture drawn? Is everybody all right with that?
Yeah.
Then our questions are all going to ask what percent of the population scored, and we'll have a whole bunch of them. First, let's find the percent that scored between 400 and 600. So, between 400 and 600, what percent of the population was between those two values?
68.
Beautiful, 68%. Then let's find the percent that scored between 500 and 700. 500's here. Ooh, that's the middle. 700's here.
So it's 68 and 95?
Well, 500 is smack dab in the middle, right?
Mm-hmm.
And so when we go to the middle, when we go to the median, we're not going to the 68. We're going right smack dab in the middle. That would be the halfway point. And so if we go to the middle, we're going to take that 95 and divide it by 2. We're taking the 95, the whole box, but we're only taking one side of it, so we divide by 2. What if I ask what percent scored between 700 and 800? This time we're looking between 700, excuse me, and 800. The 800 is the boundary for 99.7. 700 is the boundary for 95. So if we're looking between them, we're going to subtract.
97 by 95?
But we're only looking on one side. So
Mhm.
after we subtract,
Divided by 2?
beautiful. And so that's going to give me 4.7 divided by 2, or 2.35%. And then next, let's see what percent people scored below, let's say 400. So we want from 400 all the way down. When I see that word below, I'm thinking I'm going to subtract from 100. 400's attached to the 68%. So I'll take 100 minus 68. And again, because I'm only looking on one side, I'll divide by 2. So that gives me 32 divided by 2, or 16%.
Where's the 100 coming from?
Because we're going all the way down. And so whenever we go all the way down or all the way up, we're looking at the whole population. And so whenever we see the word below or whenever we see the word above, we're working with the entire group. So it would be 100%.
Okay.
Okay.
It would always, yeah, you did
Well,
say that. Subtract from 100%. Okay.
Okay. Above and below, we'll subtract from 100. And then if we just want above or if we just want below, we'll divide the difference by 2. And you see how this was real similar to the one we did before? It's just the numbers on the graph changed, but those percentages will always be the same. If we're going between two, if we're including an entire group, it's just that percent. If we're going between two boundaries, we'll subtract the 2 and divide by 2. So we'll take the difference and divide by 2. If we're looking everything below or everything above, we'll subtract from 100 and divide by 2.
So normally it would be a word problem. We have to put the pieces together, right?
Right.
Okay.
And some of the ones in my labs, they've got the graph drawn for you already, and some of them they don't.
Okay.
Okay. So this is great for giving us the percent below if we're an exact number of standard deviations away. But what if I'm not exactly at 600 or 700? What if I'm somewhere in between? Well, if I'm somewhere in between, I'm going to have to do a little bit more work. And so we're going to do a little bit more work to find what are called percentiles. Percentile is a little bit different than a percentage. When I talk about a percentile, we're saying the percent of the population at or below that score. And I'm guessing that you've heard of percentiles before. I know that I heard them an awful lot when my children were younger and I took them to the doctor. The doctor always gave me the percentile for their height and weight. And so, for example, my kids were pretty much consistently always at the 25th percentile for height, which meant that of all of the kids their age, they were taller than 25% of the kids, which also meant they were shorter than 75% of the kids. Another example, if you take a standardized test, a lot of times when they give you your results, they give you a percentile. If you score at the 50th percentile, that does not mean that you did a terrible job and you only got half the answers right. If you score at the 50th percentile, it means you did better than half of the people who took it. Your score was higher than 50% of the population. Which also means it was lower than 50% of the population. So that if you scored at the 50th percentile, it means you were right in the middle. Instead, if you'd score at, let's say, the 90th percentile, that means that your score was higher than 90% of the people who took it, which means you did pretty good. But when you talk about a percentile, it's not talking about the percent you got right or wrong on the test, but rather it's comparing you to everybody else that took that test. Like when my kids were at the 25th percentile for height, we're comparing their heights to all of the other children their age, and they were only taller than 25% of the kids, so they weren't really tall. Can everybody wrap their mind around what that percentile means? Have you seen that word before?
Yeah.
Okay. And to find percentiles, we're going to use something that's called a z-score. And a z-score is a measure of how many standard deviations you are from the mean. We're going to have a formula for the z-score. And the z-score is going to be your data value minus your mean divided by the standard deviation. So it's the data value minus the mean. And after you do that subtraction, you're going to divide it by the standard deviation. And we're going to use it to find percentiles. We're also going to use it to compare data from different populations. So what do I mean compare different populations? It's kind of like that idea of, you ever heard the expression, how do you compare apples and oranges? It's like they're different. But what we're going to do to compare them is we're going to compare each of them to their population and see which is more outstanding. So for an example, I think we had said last class that for American men, the mean height is 70 inches and the standard deviation is 4 inches. For American women, the mean height is a little bit less, 65 inches. And the standard deviation is also a little bit less, 3.5 inches. And so women are a little bit shorter than men and their heights aren't quite as spread out. I'm wondering which is more unusual. A 5 foot, which would be 60 inches, tall man. That's pretty short for a guy, right? Or a 6 foot, which would be 72 inches, tall woman. Well, 5 foot's really short for a guy, but 6 foot's really tall for a woman. Which is more unusual, which is more out of the ordinary. Because they're from different populations, they've got different means, they've got different standard deviations. To compare them, we're going to use the z-score, which again is my value minus my mean over the standard deviation. And so we're going to do this twice, once for the man and once for the woman. The z-score, this guy we're going to say is 60 inches tall. And so sometimes you see a subscript there. This is the z-score for a height of 60 inches. It would be that height, 60, minus the mean. Well, the mean for guys is 70 divided by the standard deviation for guys, which is 4. Be very careful if you're doing this with your calculator and you want to do it in one fell swoop, you need parentheses around the numerator. Rather than putting parentheses around the numerator, I usually take the time to do it in 2 parts. 60 minus 70 is -10, and that divided by 4 is -2.5. And so that tells me a lot. It tells me he's 2.5 standard deviations away from the mean. And because it's negative, it tells me he's below the mean. A negative z-score is going to mean that you're below the mean. A positive z-score is going to mean that you're above the mean. Now, this woman is 72 inches. So now we want to find the z-score for 72. but because it's a woman, we have to use her population. Her population has a mean of 65, and her population has a standard deviation of 3.5. So notice we're not comparing the woman to the man, we're comparing the woman to all the other women to see how unusual her height is. And we're comparing the man to all the other men to see how unusual his height is. This difference gives me 7 divided by 3.5 gives me 2. So this guy's 2.5 standard deviations below. And this woman's 2 standard deviations above. We know she's taller because there's z-score is positive. We know he's shorter because his z-score is negative. But do you notice 2.5 is further from the center than 2? So the man's height is more unusual. It's more standard deviations from the mean. He's further from the center. Do you see how using this z-score, we can compare that one man to all the men, we can compare that one woman to all the women and see which is more out of the ordinary. Does that make sense?
Yes.
Okay. And I'm looking, we've got 2 minutes left, and where we're going next, it's going to take more than 2 minutes. So I'm going to stop here for today. Today's Wednesday, and we will pick up from here next class. Let me stop sharing. I see a couple of people came into class after I took attendance. So let me real quick adjust attendance. If you were here on time, have a great day. We'll see you next class unless you have a question. Let's see, if you were here late, William, we got you, and Alan, we got you, and I think everybody else was here on time. Anybody have any questions?
Have a good day.
You too.